Streaming across the outstretched horizon, man challenges the wind. That elusive updraft that will give him airborne freedom. It's the adventurous spirit that expands his horizon. And it's that same adventurous nature that compels researchers and scientists to expand man's horizons. Like the glider, the search for knowledge and truth seldom follows a short, straight line. It soars around in circles, charting an unpredictable course until the answers may be known.
Research is a complex and circuitous business, and yet in the last analysis, it's quite simple. It's the process of asking questions. It's the business of learning.
It's my pleasure really to welcome you all to the Ames Research Center. The first thing we're going to do before we actually...
Here at Ames Research Center, adventurous minds explore, invent, and discover.
Research in the areas that you would suspect in space.
For the generation to come, test aircraft in a hangar are fun things to see.
Is aeronautics. Aeronautical research...
But to the men and women at Ames, these are only idle flying machines awaiting a research flight or a scientific mission.
Aeronautics tour. We're going to see things that are used in the development of new kinds of airplanes, whether they...
Flying machines have fascinated people for centuries, and research at Ames and other NASA centers has helped man to expand his horizon. Hickory, Daedalus, Columbus, Magellan, Ponce de Leon, Drake, Cabrillo, Socrates, Da Vinci, Picard, Galileo, Bacon, Bell. Discoveries have changed our lives. The amazing accomplishments of inventors, explorers, engineers, and scientists ushered in a new era of adventure and opportunity. Today, exploration and basic research continue at the National Aeronautics and Space Administration's Ames Research Center near San Francisco. Like their counterparts at the Langley, Lewis, and Flight Research Centers, the people at Ames are carrying on the tradition of others before them, searching out answers to some of the most important questions of our time, accomplishments that will continue to improve the quality of our lives. In the past, some of these goals have been realized but unheralded. Others have captured the attention of everyone on Earth.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The Apollo missions, a concerted NASA research and development program unparalleled in the history of mankind, an orchestrated group effort, and the results were clearly spectacular. At Ames, research begins here with the atom, the basic unit of matter in the universe. Now the intricate lattice structure of atoms is being exposed to the scrutiny of the human eye, made possible by the wonders of a unique and massive electron microscope. From the atom to the vast heavens above, these are the boundaries that encompass the varieties of research taking place within these laboratories. Scientists perform experiments with basic chemicals to help us understand how life evolved on Earth and if it might exist in other parts of the universe. Another clue comes to us from outer space, that is,
meteorites. Now, these meteorites are objects from outer space. We know that. They either come from asteroid belts or they come from the comets. We're uncertain of that. But the point is that they come from outside the Earth. And they bring with them a message from outside the Earth. And this message tells us something about how the universe began, and also tells us possibly something about the origin of life.
As we search for an understanding of life itself, we also look outward to the heavens with a flying observatory.
We're looking at the same heavens that astronomers have always looked at before, but looking at them, in a sense, with a new eye. We're seeing different things that has ever been possible to see before.
The infrared telescope built into this aircraft can be aimed with great accuracy at celestial objects. Tonight, it will probe the very center of the Milky Way. The airborne astronomers traveling above the water vapor in our atmosphere will indeed be seeing things that have never been seen before. The boundless solitude of space, celestial bodies like quasars, pulsars, and black holes, labels for new wonders only recently discovered in the current golden age of astronomy. Research tools. This is NASA's U-2, put to a new task, working on an Earth Resources Survey program. It's on a mission today, going 12 miles up. Its camera eyes take infrared photographs, allowing investigators to analyze and conserve our nation's resources: land, water, forest, and crop. Another important research tool at the center is ILIAC-4, the world's largest and fastest computer. One of its newest uses is to design aircraft.
Well, the issue of whether we could design an aircraft cheaper using the computer has been the underlying reason for our interest in ILIAC, of course, since the outset.
It examines theoretical shapes by calculating a plane's aerodynamic flow. It solves the most complex design problems with lightning speed. ILIAC is a great aid for engineers, but of course, it can't think. It needs the human input of creative designers like R.T. Jones, explaining his radical oblique wing design.
Well, it was evident from the theory of the swept-back wing that a single long, narrow, oblique wing panel or wing would really be better than the swept-back wing. But then, of course, you wonder, can a wing be stable and fly at a crooked angle, you know? In order to test this, I made these balsa wood models. It's a little surprising that the wing doesn't seem to care that it's going 45 degrees. Here, you watch this now.
A vision of a completely different kind of aircraft. Today, a test model. Tomorrow, it may be a familiar sight in the skies. Visions of new aircraft on the horizon. Planes that take off and land vertically and will be able to fly at jet speeds.
We're interested in aircraft that can take off vertically or take off from short fields for civilian applications for a number of reasons. For example, VSTOL aircraft, as they're commonly called, approach airports from different directions than do conventional aircraft. They use different airspace. Therefore, we can have more landings at a given airport, relieve the congestion around existing airports.
Constant research, constant testing can translate the VSTOL into reality, meaning cleaner, quieter, more convenient air transportation. Wind tunnels are the focus of aeronautical studies at the center. At Ames, there are over 24 of them. Some are able to simulate flight speeds up to 33,000 miles an hour.
Now let's try it, kids, on 3. 1, 2, 3. The sound in the wind tunnel really vibrates and resonates from all of the smooth surfaces, so try it again. Hello! 2, 3.
This is the 40 by 80 foot wind tunnel, the largest in the world. The airflow can reach a speed of 250 miles per hour. It's powered by 6 40-foot fans, driven by 36,000 horsepower. Virtually every American aircraft, civilian and military, has spent many hours being tested here. Today, a VSTOL research plane is having its workout.
And so if we take the jet technology and marry that with the vertical capability of the helicopter into a vertical takeoff jet aircraft, then we have the advantages of both. We can take off from a confined space, get into horizontal flight, and cruise very efficiently with a jet, and then come back and land vertically again.
Take off vertically, land vertically. An aircraft made possible by aeronautical research and wind tunnel testing. This is what you see if you're a pilot landing an airliner. But there's an easier and cheaper way to fly. The Ames Flight Simulator for Advanced Aircraft. Everything you see and hear in that machine is just like the real thing. The pilot gets a preview of an airplane's feel, its performance capabilities, its handling characteristics. It's an advanced research tool which allows engineers to design and evaluate aircraft performance while remaining safe on the ground. The simulator also is used by astronauts to prepare for landings of the new Space Shuttle, America's newest manned spaceflight venture. Even before the Space Shuttle begins its Earth-orbiting career, NASA will be landing an unmanned spacecraft on Mars. One of its primary missions is to search for life.
If we find life on the planet Mars, I believe it will have very profound scientific implications and ultimately very profound philosophical implications. From the scientific point of view, the biologists will be tremendously excited about this discovery because it will open up a second sample of living matter in the universe.
July 4th, 1976, a key date in American history. And it's an important day for another reason. It marks the arrival of the Viking lander. Delicate biological experiments fed by Viking's mechanical arm may tell us whether or not there are living creatures in the Martian soil. A mechanical arm, another research project at Ames, is an experiment in advanced cybernetics, a system linking a computer with the human body. A man can move his arm here, and a duplicate arm will do his bidding there, even at long distances, as skillfully as it follows his orders in a chess game. It could work in nuclear labs, handle corrosive materials, use tools in a mine thousands of feet down, or move a queen to king's pawn third. Checkmate. December 2nd, 1974. On that Sunday, Pioneer 11 flashed past Jupiter at 107,000 miles an hour. It is now on its way to Saturn, while sister ship Pioneer 10, its mission complete, is wending its way out of the solar system. Pioneer 10 and Pioneer 11 have become legends in scientific adventure. They have unveiled the mysteries of the giant planet Jupiter. They've set all-time records in speed and distance. Their close-up color pictures of Jupiter and its great red spot may have given us a record of what the Earth once was like, a glimpse of a planet that is almost a star. Pioneer truly has become a pioneer in space exploration.
Exploration of the planets and exploration of the oceans are really not that much different, represented by the spacecraft Pioneer here and the exploration ship. The objectives are basically the same. They're scientific, and the need for mankind to explore his universe, whether it's the oceans or the solar system in the case of the Pioneer. Mankind has a need to get out there, find out what's there from a scientific standpoint, and to satisfy his need to understand why he is here and where he lives.
Research is a complex and circuitous business. The answers are there, waiting to be understood, and the adventure is in the understanding. The future for our planet and those of us who populate her colorful continents depends largely on our ability to search out the unknown, whether it be on our own planet within our solar system or in the vast outer oceans of space. Man's inquisitive nature demands he explore, invent, and discover. Like gliding through a cloud-free sky, research can be a marvelous adventure for those whose lives are dedicated to seeking understanding for the betterment of all mankind.